So this is week 4 of our data analysis and statistics and part 2 of our video series. So we're going to look at some different activities with 7th grade and 8th grade standards. And if we look at the big ideas, just different ways that we can collect data. So we'll look at determining whether a collection of data comes from a sample or whether it comes from a population. We'll look at graphs, and whether those are histograms or dot plots. We can look at and determine whether, if we pulled a random sample, is it coming from a certain population or not. And then we're going to look at linear relationships and the patterns of association. So we'll see if something has a positive relationship, linear relationship, or negative in regard to scatter plots. And then to cap that off, we'll look at being able to write an equation based on the data that's given. So the first one, this activity, we're going to indicate whether the statements that are given, whether the answer to this statistical question comes from a population or a sample. So 54% of responders to a poll at a university indicated that wealth needed to be distributed more evenly among people. Well, the population, if we're looking at the population, that would equal the entire university. Well, we're only looking at 54% of the responders. So 54% of the responders, that is going to represent that we're looking at a sample. Part B, are students in the Bay Shore School District proficient on the state assessments in mathematics? So in 2013, after all the tests were taken by the students, the Bay Shore schools were evaluated, and over 52% of those students were above proficient on the state assessment. Well, when we see right here, it says in 2013, after all the students. So the population would be all students. So this does represent a population. Part C, does talking on a cell phone while driving distract people? Researchers measured the reaction times of 38 study participants as they talked on mobile phones and found that the average rate of distraction from their driving was rated 2.25 out of 5. So we would say that the study had 38 participants, and this is a sample because 2.25 out of 5 would be a sample statistic. So this would represent a sample. Part D, did most people living in New York in 2010 have at least a high school education? So based on the data collected from all New York residents. So when we read that, that's a good indication that we are dealing with a population, because the census looks at all the people. So, and we're seeing that approximately 85% had at least a high school education. So this is looking at the population. Part E, were there more deaths than births in the United States between July 2011 and July 2012? So we're looking at 1 year, and the data from Health Service Agency indicated that there were 2% more deaths than births in the United States during that time frame. Well, so Part E, when we're seeing that 2% would be a sample, because the census didn't occur at that time. The census would occurred in 2010. So in 2010 was a census at that time, and then we're looking at 2011 to 2012. So this would be a sample during that time frame. And then part F, what's the 5th best-selling book in the United States based on sales of books in the U.S.? So the 5th selling book, which means the population of all books to be recorded, you would look for the 5th best selling. And so that represents your population. All right, look at our next question. We want to talk about random sampling, which is going to give you a very good indication of a truer reading of your population. But remember, random kind of eliminates some of the bias, and it eliminates giving precedent to one or more groups of people or whatnot when you're just choosing people or objects or whatnot from a pool of total. However, if it's a random sample, you've got some sort of methodology to your choice. For instance, if you were wanting to choose students from a school, could be that you chose 10 students from every classroom in the first period that's going on. You went to every classroom and chose, let's say, 10 people. And that would kind of give you a random sample of your school. You could look at your list of students in the entire school. So let's say you had 7th and 8th grade, or in 7th grade and 8th grade both in one school, and you chose just 7th grade you wanted to do your study on. Well, you could list all the students in alphabetical order and take every 10th person, let's say. And that would allow for everyone to have an equal opportunity to be chosen. So the question here says, do you think random samples from the same population will be fairly similar? And yes, a random sample should represent a good generalization of your population. And so we would say yes, because random samples give a good representation of the population. That's why it's also good to make sure your sample size is adequate. You don't want to choose 5 students out of a school of 200 and then try to generalize an idea. You would want to take a random sample of a decent amount of students to determine how that would represent the population. Down below, you see that here you've got a dot plot of population of penny ages. So remember what dot plots represent. They represent your frequency of how many you see. And so we're looking at a whole bunch of pennies here that are just newly minted. And then you've got a couple over here that may be around 48, 49, 50 years old. And so you're thinking about your balance point would be somewhere, let's see, balance point probably somewhere around here. So it does show that the graph may be skewed slightly to the right. Okay, let's look at part C. Look at the distribution of years. So now we're looking at box plot. And these box plots represent different random samples. So I am going to come back and look at this graph here. So when I reference these box plots, I'm really referencing our original population. So this says, looking at the distributions, which of the following box plots seem like they might not have come from a random sample from that distribution? Well, if we look at the penny 1 box plot, this looks like it may not be a random sample. Now here's why. If you look at your minimum amounts, your minimum looks like it's somewhere around 9, and your maximum looks like it's somewhere around 35, and your median looks like it's somewhere around 15. So if we go back and look at the original, minimum of that minimum of what did I say, 9 and maximum 35. So minimum of 9, maximum of 35, somewhere in there. It doesn't really represent what's going on over here or over here. So we're kind of taking a little bit more of the middle. So that's why I would say that box plot number 1 wouldn't represent a very good random sample. But if you look at box plot 2 and box plot 3, notice that it goes all the way to 0. This one goes to 49. This one goes to 40. The medians are fairly close together. And we see we run from about 5 to 35 with our first quartile and third quartile. So 5 to 35. So now we're looking at somewhere in here to here as our quartiles. And we do represent 0 up to 40 on both of these. So the box plots for 2 and 3 would represent a random sample. So it does help to look at the medians. It helps to look at the minimums, the maximums, look at your quartiles to make a good decision whether that's coming from, that's a good random sample from the population. So the next activity, here's what we're looking at. We're looking at a sample right along here. There's our sample. And notice where the majority of the dots are located over here from around 58 to maybe 90. So given the following samples of scores on fitness tests, from which of the following populations might the sample have been chosen? So you're looking at grade 7, grade 8, grade 6, and grade 5. Well, just seeing where these numbers are being pulled from the sample, you really eliminate 7 because the highest one on grade 7 is not even in the range of the sample. So grade 7 is out. And I would even venture a guess of grade 5. So I would even say 5 grade 5 and 7. They would not represent the population. Now you look at grade 8 and grade 6. Notice where most of the data is here and most of the data is here. Look how that kind of matches up with the sample. So we would say that grade 6 and 8 would represent the population of that given sample. So just a kind of a summary of the 7th grade statistics that we're looking at. Data from a population, that value is called a population characteristic, and then data from a sample is called a sample statistic. And sample statistics help us learn about the population. All right, so let's look at 8th grade. And when we say bivariate data, that's just a very fancy word of saying that we're looking at X and Y values, independent and dependent. We're looking at 2 variables and looking at the observations. So here we're looking at data on 13 model cars. And the ordered pairs given will be X and Y, where X is weight and Y is fuel efficiency. And then we'll see, what's the fuel efficiency and the weight of the car when we're looking at certain observations. So looking at this, I already have one that's created for you. So we're going to look at graphing the coordinates. Again, we have all of our points, and I want you to go ahead and pause the video. I want you to go ahead and take the time to plot the weight in pounds, that's your x-axis, and your fuel efficiency will be your y. And so the first one is done for you at 3,200 pounds, roughly. We've got 23 miles per gallon. So there's your first order pair. And so go ahead and take the time to plot those. I'll give you a few minutes. All right, so now that you've plotted 13 ordered pairs, you can kind of see patterns in the scatter plot. And so you would think, well, what does this imply about the relationship? And we would say as the weight increases, the fuel efficiency decreases. And that's how you would state a lot of your different patterns. So when you're talking about linear relationships, especially linear in this regard, we're talking as the x values are doing something, what are the y values doing? So the x values could increase, the y values could increase. The x values could increase, the y values could decrease. And in this case, we're seeing as one increases, the other is decreasing. And I didn't ask for this, but what you could do is create a line of best fit, which something like this, where it kind of gives you a way of predicting. And so if I asked you, what would a car that's 6,000 pounds, what would be the fuel efficiency approximately? So you're going to come down here and find your 6,000 and then look and say, oh, it's about, probably about 8 or 9 miles per gallon. Not very good, but if you also go on the other end and look at something that's maybe 2,000, somewhere around in here, and follow that up, so you can see you're up here at about 30 miles per gallon. So it gives you ways to predict using a line of best fit. All right, this next one, we're going to look at the relationship between crocodilians and body mass and diet. So we would say that X represents the pounds in body mass for the crocodile, and then we would say Y would represent the bite force in pounds. So we can see that think about, this is not in any typical order, but what the next screen will show is what this would look like on a graph. So body mass is your X and bite force is your Y. And so what we would state is, as the body mass increases, the bite force increases. And so this would show some sort of positive linear relationship, as opposed to the other one with the fuel represented a negative linear relationship. So this would allow you to make some different observations. If you said, well, what would a 175-pound crocodilian weigh? Well, the bite force would be somewhere around 600 pounds approximately. If there was a 500-pound crocodilian, we would see that that bite force would be somewhere around 1,400 to 1,500 pounds. And then we did describe the relationship between the body mass. So as the body mass increases, we're seeing the bite force increase. So that creates that linear relationship here. And then we drew a line of best fit to try to create that trend line. Now, based on the trend line, we can predict bite force for a crocodilian that weighs 220 pounds. So here would be approximately 250. So maybe somewhere around here, 225. And if we had our line of best fit looking something like that, that maybe around that 800-pound mark would give us a good predicted value. And then we have students that decided to draw lines of best fit. And so we've got Souls and Patties and Marissas and Taylors. So you think about Marissa's, Marissa left a lot of the data underneath her line. So she didn't really go through very many of the points. And Taylor seemed to go through most of them here, but left a lot of them up here. And then Soul seemed to leave some of these. I would say that probably Patty is probably, looks like it's a good fit. And so again, let me just kind of review back over that again. So we would say, what could we say about Soul's line of best fit? I would say in general, Soul looks like it's overestimating a little more for heavier crocodiles and underestimating the bite force for crocodiles that do not weigh very much. So kind of overestimating up here, underestimating down here. All right, so let's go to another color and let's look at Marissa. looks like Marissa's line overestimates the bite force because almost all the points are below. So you're seeing mostly these points, she's overestimated that with her line of best fit. So she's left a lot of those below. And really, she's looked at 1, 2, 3, 4, 5. Her line went through 5 points and left a whole lot of others below that, so that would give you that overestimate. And then if you look at Taylor's line tends to underestimate the bite force of several. So you can see that a lot of these points, he's below that. So he's kind of underestimating that. Patty's probably the better one. And so because Patty's looks like it fits the data pretty well and should produce good estimates, and her line is fairly close to, so you see it's right in here. It's kind of in between a lot of them. Remember, a line of best fit doesn't have to go through all of them, but Patty's looks like hers would be the best. And that's what I did here. I just kind of verbally explained. You can rewind the video if you like again, as I discussed Sol's line and Patty's and Marissa's and Taylor's. Now, let's look at how we would create a line of best fit and determine an equation to do so. So if we're looking at points that this line could go through. So if we're looking at something like this, we could probably say maybe one of these points. Maybe this one here, where we could try to see if that line would go through. So it kind of gives us a good, if I wanted to use those 2 points to create that. So I'm picking 2 points. That's my first part there. So now we look at some of the body mass that represents that. And that would represent probably, so I would say maybe 28 and 230 would be an order pair that could go through. And then if we picked another one, we could say maybe the 280, that would be around 3 something. Maybe we could say approximately 300 and 1,150. So we've picked the 2 points there. And now we want to find the slope. Well, to do that, remember, slope is your change in y divided by your change in x. So we want to go ahead and do that calculation. So I'm going to look at this y value and this y value, and I'm going to subtract those. And then I'm going to come back and grab that 300 minus the 28. So that's going to give me a slope. So 1,150 take away 230, and that's going to give me 920. And then 300 take away 28, that's going to give me 272. So what is 920 divided by 272? And that's going to be about 3 3/38 approximately for the slope. So now we need to find the y-intercept, because we picked 2 points, we did find the slope. Now, to do that, we would just use our y equals mx plus b formula, and I just need to pick I'm just going to pick one of these points. I'm going to pick 300 and 1,150. So 300 in the place of x, 3 and 38 hundredths in the place of m. I do not know my intercept, and I know that my y value is 1,150. So I need to take that 3 and 38 hundredths and multiply it by 300, and I'm going to get approximately 1,000, we'll say 15. And then I'm going to take the 1,150 and take away the 1,015, and I get about 135. So what does that mean? Well, that's your y-intercept. So your equation for your line of best fit would be y equals 3 and 38 hundredths x plus 135. That would be the equation to help determine a predictive model for this bite force versus body mass. So if I wanted to use that prediction and figure out a crocodilian that weighs 200 pounds, well, then I would just substitute 200 in for x, and I would take the 200 and multiply it by 3 and 38 hundredths, and then I would add it to 135, and I would get about 811. And so 200 is right here, and that's going to model somewhere around that 811. So it's a representation it's pretty close to that. So, and that's how you find your creating your line of best fit. Pick a couple of points, find the slope, determine your y-intercept, which we did right here. And then once you find your y-intercept, you just piece them together and you have your equation. All right, let's look at another problem where we have the scatter plot shows the age in years and the price in dollars used for compact cars that were advertised in a local newspaper. So based on the scatter plot, describe the relationship between the age and the price. So we would say as the, kind of how we would always start kind of our description of this, as the age in years increases, we would say the price decreases. Well, that would show a negative correlation. So as one increases, the other one decreases. This would be a negative linear association or a negative linear relationship to model the data. So then Nora, she drew a line that she thought was close to as many points and found the equation of the line, and she used the points 13 and 6,000, and she used the points 7 and 12,000. Now, why did she use that? Think about using those points. Is 7 and 12,000 is a point that line would go through. And then if you look at 13 and 12,000, or 13 and 6,000, well, there's also another point that line goes through. So that's why up here you say, explain why those points, why it was, why was it easy? Because the points of the intersection, the grid lines and the line of best fit intersect. So it's a little easier to determine the coordinates to use to find your slope. So in order to do that, so we're just going to write the equation. So again, she used 13 and 6,000. And she used the points 7 and 12,000. Let me rewrite that. It's a little sloppy. 7 and 12,000. So we're going to use the slope formula. So y minus y divided by x minus x. So we're going to take 12,000. I'm going to start with this y and then subtract this y. And this is a common error that students make when they're finding the slope of a line, is they tend to go with the x values in the numerator instead of the y values. But remember, what we're looking for is the rate of change, and the change is how the y values change divided by how the x values change. So that gives you that rise and run idea. And so since I started with 12,000, I've got to come back and grab 7 minus 13. Well, it should be negative. We've already identified that as one value increases, the other one decreases. So I should see 12,000 minus 6,000 is 6,000, and 7 minus 13 is negative 6. So our answer is going to be negative, and it's going to be a negative 1,000. So what does that mean? Well, that means that for every the price is going to decrease $1,000 every year. So we know our slope, and now you get to choose which point do you want to choose. So I'm going to choose the second one. So to write my equation, I'm just going to substitute into the slope-intercept form. So 12,000 will substitute in for y. The slope was negative 1,000. The x value was 7, and I'm looking for the intercept b. So this would be 12,000 equals negative 7,000 plus b. So to solve for b, I need to add the 7,000 to the other side to keep it balanced. So the intercept would be 19,000. So the equation of the line up here should be y equals negative 1,000 x plus 19,000. Slope is negative 1,000. The y-intercept is 19,000. And so that's our final example with determining lines of best fit, determining the correlation, the pattern of association. Is it going to be a positive association or negative association? So remember, if you're looking at, you've got your different graphs here, and if you see something that looks more like this, where you can see the data does have some sort of trend, that would be your positive linear association. If we look at something like this, where it fits a nice trend line that's going in the negative direction, so this would be a negative linear association. And then you could have something that looks like this, where it's really difficult to tell what's going on. So we would say that there is no correlation. There's no pattern of association with something like this. So remember, a line of best fit can help represent a trend in a scatter plot, and then we can determine equations using picking 2 points, finding the slope, determining the y-intercept, create that equation, and then we can use that equation to help in a predictive manner. So that's the end of this video series, part 2, where we're looking at concepts of data analysis.